Hello everyone. This is my second lecture on mechanics, the chapter Simple Harmonic Motion. In this lecture, I will discuss general solution of SHM. So, you have remembered the properties of SHM. The particle must moves on a straight line. The acceleration is directed towards a fixed point O and it's proportional to the displacement. The equation is d2x by dt square equal to minus mu x. So in a SHM, if the amplitude is not given, amplitude the greatest distance or the maximum distance. So if the amplitude is not given, it is said to be the general SHM. So let x O x dash be the straight line in which O be the fixed point. A particle starts to move from x and after time t, let p be the position of the particle such that OP equal to x. Then d2x by dt square is proportional to x by definition of SHM. And this implies d2x by dt square equal to minus mu x. Give it as equation 1. Mu is the proportionality constant and negative sign is taken because x decreases with time t. Multiplying equation 1 by 2 dx by dt, we get 2 dx by dt d2 square by dt square equal to minus mu x 2 dx by dt. So this can be written as d by dt dx by dt whole square equal to minus mu d by dt x square. Integrating both sides with respect to t, we have dx by dt whole square equal to minus mu x square plus c1. Since amplitude is not given here and the motion is SHM and c1 is arbitrary constant, so as in the previous theorem, we will take the value of c1 as mu capital A square where A is the arbitrary constant. So equation 2 implies dx by dt whole square equal to mu capital A square minus x square. This implies dx by dt is minus under root mu under root A square minus x square. Give it as equation 3. This is the expression for velocity. So we have taken negative sign here as x decreases with time t. So from 3 we can write that minus dx by under root a square minus x square equal to under root mu dt. So integrating both sides we will get cos inverse x by a is equal to under root mu t plus epsilon, and this implies x is equal to capital A cos root mu t plus epsilon. Give it as equation 4. This is the expression for displacement. Here epsilon is integrating constant and this is called epoch of motion, and the angle under root mu t plus epsilon is called argument of motion. The difference between the time t and that when the particle is at maximum distance from fixed point is called phase of motion. So now the particle will be at maximum distance when cos root mu t plus epsilon is maximum because capital A is constant. And we know that the maximum value of cos root mu t plus epsilon is 1. So under root mu t plus epsilon will be 0 as cos 0 degree is equal to 1. So this implies t is equal to minus epsilon by root mu is equal to t naught. Let it be t naught. So phase at time t is equal to t minus t naught, the difference between time t and the time of the maximum displacement. So t minus t naught, putting the value of t naught, which is minus epsilon by root mu, we will get t plus epsilon by root mu, which is equal to under root mu t plus epsilon by root mu.